You're listening to an article by Eminent, an expert in aerospace engineering and technical consultation. See us at eminent-design.com. Aircraft equipment is often exposed to a range of fluids, from hydraulic fluids and fuel to cleaning and de-icing agents. RTCA DO 160. Section 11, Fluids Susceptibility. Testing assesses equipment's durability and resistance when exposed to these operational fluids, ensuring it remains functional and safe without material degradation. This testing is crucial for equipment installed in areas prone to fluid exposure, verifying that components can withstand various liquids without compromising performance or safety. In this article, we'll explore Section 11, covering testing categories, common failures, mitigation strategies, and the importance of this testing for airworthiness and flight safety. The importance of RTCA DO 160. Section 11 for flight safety and airworthiness. Fluid exposure, especially over time, can lead to corrosion, material breakdown, and even electrical malfunctions. Section 11 ensures that equipment used on aircraft can withstand exposure to operational fluids, supporting airworthiness by reducing fluid-related failures. Compliance with this testing is essential for maintaining safety and reliability in fluid-exposed environments. Key categories of fluids. Susceptibility testing in DO 160. Section 11. Section 11 is divided into categories based on the types of fluids that equipment may encounter, simulating various fluid exposures. FAA standards and customer-specific requirements help determine the appropriate testing category, aligning with the equipment's location and operational needs. Category F1. This category tests equipment exposure to fluids like jet fuel, oils, and standard cleaning agents, common near engines or fuel systems. Failures may include seal degradation, corrosion, or contact deterioration. Mitigation. Fuel-resistant seals, corrosion-resistant metals, and fluid-tight enclosures help prevent damage in these areas. Category F2. Designed for equipment in areas exposed to hydraulic oils or de-icing agents, Category F2 simulates moderate exposure to these chemicals. Failures include swelling of rubber components and insulation breakdown. Mitigation. Using chemically resistant materials, such as high-grade rubber and reinforced insulation, ensures durability under moderate chemical exposure. Category F3. For interior equipment that may come into contact with disinfectants or cleaning agents, Category F3 tests for resilience against chemical cleaners. Failures may include discoloration, material erosion, or adhesive failures. Mitigation. Selecting chemical-resistant adhesives and applying non-reactive coatings improves durability against frequent cleaning. Category F4. This high-exposure category simulates prolonged contact with both hydraulic fluids and fuel, testing for maximum fluid resilience. Failures often include severe corrosion or extensive seal breakdown. Mitigation. Implementing high-performance, chemically resistant alloys and designing with fluid-tight seals in high-risk areas helps equipment endure severe conditions. Typical failures in fluids susceptibility testing and their mitigations. Fluid susceptibility testing can reveal specific weaknesses that impact equipment functionality, particularly in areas exposed to aggressive chemicals or high fluid contact. Corrosion of metal components, jet fuel, and hydraulic fluids can cause corrosion, weakening structural integrity. Mitigation. Using corrosion-resistant metals and applying protective coatings helps shield equipment from chemical exposure. Seal degradation. Prolonged fluid exposure can deteriorate seals, leading to leaks and fluid ingress. Mitigation. Using fluid-resistant, high-grade seals and regularly inspecting for wear ensures secure containment. Material swelling and deformation. Certain fluids cause materials like rubber or plastic to swell or degrade, reducing performance. Mitigation. Choosing chemically stable materials that resist swelling maintains functionality in fluid-prone environments. Electrical insulation. Breakdown. Fluid ingress can compromise insulation, risking short circuits and malfunctions. Mitigation. Moisture-proof insulation and fluid-tight enclosures protect sensitive components from fluid-related damage. Rationale behind fluid susceptibility testing. Fluid susceptibility testing under DO 160 Section 11 is critical to ensure equipment can perform reliably in environments where fluid exposure is frequent or sustained. Testing categories simulate real-world fluid contact scenarios, confirming that equipment maintains durability and functionality despite exposure to potentially harmful chemicals. By aligning testing categories with FAA regulations and specific customer needs, Section 11 testing supports airworthiness and enhances safety. Consulting for RTCA DO 160. Section 11 testing, how Eminent can support your certification needs. At Eminent, we provide expert consulting for DO 160 Section 11 certification, offering guidance on design strategies that protect against fluid-related risks. If you encounter challenges in fluid susceptibility compliance, our team can help implement effective solutions to meet certification standards and ensure your equipment is ready for airborne applications. Thank you for listening. Please check out our articles on other DO 160 sections.